So all the mess that we did in the previous couple of videos was called subnetting and VLSM. Let me tell you something. Subnetting was just to know the subnet mask. Subnet mask always ranges from 8 to 32. There is nothing called /7. And you have seen from the 4 examples that we solved that the smaller the subnet mask, the bigger the amount of IP addresses that we got. So /8 gave us 16 million, /16 gave us 65,000, /24 gave us 200 something, /27 gave us only 32 IP, and the valid was only 30. Yeah, so the smallest the IP address, the bigger the amount of valid IP. The smaller the subnet mask, the bigger the amount of valid IP addresses. How we wrote subnet mask /something, or decimal, or binary. And then we talked about the variable length subnet mask. I did not mention the name, I'm sorry for that, VLSM, but it's the opposite of subnetting. Not just knowing the subnet mask, but well, you know the subnet mask like from knowing the amount of ones and zeros, and that's it. But the VLSM is the 3 examples of the previous video, by obtaining the network ID, broadcast ID, and the valid IP addresses that range between them, and that's it. That was the VLSM. Today we will talk about 2 different things, and these are the classes and the CIDR. Yeah, and that is that. So see, the classes, actually IPv4, when it was just firstly released to the world, it was already classified before even releasing, before officially releasing. So it was classified into 5 classes. 3 of them you care about in CCNA level, 2 extra you will care about later in CCNP and CCIE. Not always, not even. You care about only the first 3 for now. I will tell you why. Because class A, you know that IP addresses can start from 0 dot something, and it can end until it can end with 255 all the way. So it can start from all zeros to all 255s, and the total will be 4,294,000,000 something. So when it was first released, it was released on 5 classes, as I said many times. Class A started from the very first 1 dot something, 1 dot whatever, and it ended at the end of 126. So 126.0 is the beginning, like 126.000 is the beginning. 126.0.0.255 is still not the full. You need to fill all of the let's say you need to fill all of the octets. So 126 dot all of them. And yes, that is something extremely basic that I forget to tell you in the previous couple of videos. Knowing the amount of ones and the amount of zeros is knowing the network part and the host part that I mentioned at the beginning of IPv4. Do you remember the pizza guy and the address, and the network part and the host part? The network part is the part that is the octet that has ones below it in the subnet mask, and the host part is the part that has zeros. Like what? Like one of the very basic examples in the previous video. If you're 10.0.0.0/8, and we know that this is 1111.1111.0.0.0s all the way, 8 zeros, 8 zeros, 8 0. The octet that has ones is the octet that's called the network part, and the octets that has zeros are the octets that are called the host part. This is very basic, and I'm sorry to not say it in that time, mention it previously, but we are still at the beginning of this course. So what does that mean? Why would I care knowing the network from the host? Because you can change the house, you can't change the street. You are not the government. What I mean simply the network part cannot be changed, while the host part can be changed. That's why I kept modifying these until I reached the maximum of 255. Then I jumped until I replicated the same thing. Then I jumped until I replicated the same thing. Finally, we discovered the broadcast was 10.255.255.255, and that was the maximum. When it was /16, in /16 we had the first 2 octets filled with ones, the second 2 octets filled with zeros. That means that the first 2 octets are the network part, and the second 2 octets are the host parts. Yes, so we cannot manipulate 172.16 at all when we want to keep changing the IP addresses until we reach the last valid one and the broadcast. We can only change these, and we did until we reached 172.16.255.255. That was something very important that I forgot to mention, and now I believe, or I wish, that you got the idea. So now, again, class A started from 1, the very beginning of 1, all of it. So all the 1 dot whatever you want until 126, the end of 126. So if I ever worked someday, studied someday, and you read an IP address of 1 dot whatever, just whatever, it's a class A. 2 dot whatever, it's class A. 10 dot whatever, class A. 50 dot whatever, it's class A. Until you reach 100, it's class A. 120 dot something, you are still class A. Even 125 and 126 are class A. I don't care about the second 3 octets. Why I don't? Because I care about the network octet in class A, because class A, all of it, all of the IP addresses that participates in class A are /8. Yes, that is the catch. So since all the IP addresses in /A in class A are /8, that means that I always care about the first octet. I look at the first octet. If the first octet was a number that ranged from 1 to 126, then this IP address is definitely a class A. That's it, we are done. So class A starts from 1, ends with 126, the end of 126, and that's it. Class B always has /16, and it starts from the beginning of 128 until we reach the end of 190 to 191. So 128.0 will be the network part, and 0.0 will be the host part. Until this is filled, so you will need to start a new network, and the new network will be 128.1, and the host parts keep changing until they are filled, because you're on /16. In /16, you can't change the first 2 parts, you can only play with the second 2 octets or the second 2 parts. When they are filled, you jump, when they are filled, you jump, and so on and so forth. What I mean is 128.0.whatever cannot communicate at all with something called 128.1.whatever. At all. Impossible in the same broadcast domain, because this is a network part, fixed, you cannot manipulate, and this network part can only communicate with another IP address that has the same network part. So whatever here, I don't care, but I care about these to be identical. As long as they are not identical, these two cannot talk. Regarding subnet class B, or regarding subnet 16, in class A, same thing. 1 can communicate with 1 dot whatever, but 1 dot whatever can never communicate with 2 dot whatever in the same broadcast domain. When it goes to class C, then 192.0.0.0, let me tell you, /24 means you have 24 ones, so that would be the first 3 octets. The first 3 octets are locked as network part, and the 4th octet is the host part. So I can only play with the 4th one. The first 3 I cannot change at all. So the idea is 192.0.0.whatever, impossible to communicate with 192.0.1.whatever, impossible to communicate with 192.1.0.whatever. So you need always to have the first 3 octets identical in a /24 so that they can communicate, so that only the 4th one can be manipulated and communicated with the others. This is the idea, and that is the catch. So class C starts from 192 until the very end of 233. This is only a classification. This is not to say that all of these guys can communicate together, or all of these guys can communicate together. No. This is just to say they are subnet masks, because subnet masks were fixed at that time. But if you remember the first example of the previous video, I wrote /27, and that subnet mask actually came from the future, and I will tell you that in a minute, okay? But the very first basics of networking and subnetting was only /8, 16, and 24. There was nothing called /9, /15, /17, /25, 23, /29 at all. All of these main classes were there. This is a very old-fashioned thing. And there was something called class D that starts from 2 to 4 until the end of 239. This one is reserved. You can never use it for multicast purposes, and you will study multicast in the CCNP in core. And there is something called class E /8, starts from 240 until the end edge of the word that Sinbad discovered, or you might call it Sinbad in your culture, that discovered when they go with their ship before. So this is the last edge of the word because it's not flat. Anyway, okay, so this one is reserved as well for future, for science purposes that we can never use. This one is reserved for multicast. We will use, but in multicast purposes. What is multicast? This one is explained in CCNP, and some of you are wondering right now, I believe, you lied saying to us IP addresses start from 0 dot something, yet class A starts from 1 dot something. Where is the 0 dot something? Reserved for the producers and developers. Okay, it exists, but it's reserved. Number one. Number two, while class A ends with the end of 126, yet class B starts with 128. There is a 127 missing. Yes, Microsoft bought that and called that the loopback address, so it's reserved for Microsoft purposes. Leave it. This is the exception number two. Exception number three is not cleared in the table. It's called the APIPA, automatic private IP addressing. It has the range of 169 to 54.0.0/16. This entire subnet that has /16, so it definitely has 65,000 IP address or more. This is reserved for Microsoft as well, to assign something that you'll understand in chapter 4 completely with hands-on labs. It's called APIPA, automatic private IP addressing, APIPA, and that's it. This is what I wanted to tell you in this video. Okay, so far 5 classes. You care as a CCNA only with the first 3 classes, and that's it, only with the first 3. So this is what I want you to know. And also again, there is something important that we need to know, and that important thing will be class A was /8, /16, /24, /8, so whenever you want to design a network, and in that network you just want it, from the matter of design, you just wanted to use an IP address named 130 dot whatever, based on the old system. 130 varies here between 128 and 191, so it's class B, so it's /16. So whatever, I don't care about the number here, it's /16, and because it's /16, then these numbers always have 65,000 IP address in their network. You might say, I just wanted to design a small 50 address network, and that's it. I have only 50 employees in my network. This is the only thing that I wanted to design, and I just wanted to innocently use the IP address of 130. You are telling me right now that I am wasting thousands of thousands, more than 60,000 IP address by using this subnet? Yes, based on the classes you are. So this leads to the complete exhaustion of IPv4 in a few months. Then that should have definitely be exhausted in the 90s or the 80s, not here in 2020, not right now. Solution was remove the classes and make it a classless. So the classless interdomain routing, the CIDR, is a new technique, not in this video, you need a breath, is a new technique that we will need to adopt and understand and study, that will allow us to obtain a subnet mask only based on our needs, not to waste a /16 for a small network that has 50 employees. No, from now on, whatever IP address can be on whatever subnet mask, and you can know your own network ID, broadcast ID, valid IP addresses, and whatever. And that's it. As simple as that. How? In the upcoming video, before we are done with IPv4. Thank you.